There are many different types of people in the world. Some are very calm, and not much bothers them. Others can get agitated on occasion, and some get very animated and upset about pretty much anything. This is an analogy for metallic elements. Some are highly reactive with many compounds. Some only react with certain compounds, and others hardly react at all. Let's go through the different types of metal reactions. There are a few highly reactive metals, which react with dilute acids, water, and oxygen, and include potassium, sodium, lithium, and calcium, to name a few. These metals are part of the alkali metal and alkaline earth metals, which are the two columns on the far left side of the periodic table. Let's look at the reaction of sodium with a dilute acid, water, and oxygen. Sodium reacts with dilute hydrochloric acid, according to the following equation. If we saw this reaction take place, we would see hydrogen bubbles forming in the solution. Let's break this reaction down to see what's happening in terms of electrons transferring between the reactants. This net ionic equation shows the two sodium atoms on the reactant side are neutral. They have +1 charges on the product side. To coincide with that, the hydrogen ions on the reactant side have a +1 charge, and the hydrogen molecule on the product side is neutral. For this to happen, the sodium atoms donate 1 electron each to each hydrogen ion. The chlorine ion doesn't change during the reaction. Let's see how sodium reacts with water. Sodium reacts fairly violently with water. Hydrogen gas is generated, which can be observed in the formation of bubbles in the solution. Another indicator a reaction occurs is the change in the pH. Initially, the water has a pH of 7, which is neutral. In addition to hydrogen being generated, sodium hydroxide is generated, which is a base. The pH of the resulting solution will be greater than 7. The equation for this reaction is... Let's see how sodium reacts with oxygen. Elemental sodium does react with oxygen, which is why it has to be stored in special oil. The reaction with sodium and oxygen is... There is also a transfer of electrons in this reaction, from the sodium atoms to the oxygen atoms. When sodium reacts with oxygen, it turns a yellowish color. We have discussed a highly reactive metals reaction with a dilute acid, water, and oxygen. Will a less reactive metal react the same way with these substances? Let's find out. Less reactive metals react with acids and oxygen, but not water, and include several transition metals such as zinc, iron, and tin. Let's look at how zinc reacts with a dilute acid, water, and oxygen. Zinc reacts with dilute acids, and we'll see the same electron transfer in this reaction as we did when sodium reacted with a dilute acid. Zinc starts as a neutral atom and ends up with a +2 charge due to its losing 2 electrons to 2 hydrogen atoms. Let's look at zinc's reaction with dilute hydrochloric acid. The next reaction we'll investigate will be between zinc and water. Zinc isn't reactive enough to react readily with water. In fact, this is why zinc coatings are put on metals that are going to be used in outdoor settings. These zinc-coated metals are called galvanized metals. Does zinc react with oxygen? Let's see. Zinc reacts with oxygen through the transfer of electrons from the zinc atoms to the oxygen atoms. The reaction is... Evidence this reaction has occurred is through the change in the appearance of the substance, which is known as corrosion. Let's now investigate the least reactive types of metal and how they react with dilute acids, water, and oxygen. Least reactive metals only react with oxygen. Some of the least reactive metals are the heavier transition metals, such as copper, silver, mercury, and gold. Gold is so non-reactive that it's a very popular metal to use in jewelry. Let's go through the reaction of silver with a dilute acid, water, and oxygen. Silver doesn't react with either dilute acids or water, but it does react with oxygen. Maybe you've seen people polishing silverware before a special event. They do this because a layer of silver oxide is generated on the surface of the silverware. The polishing removes this oxide layer. Let's look at the reaction of silver with oxygen. The transfer of electrons occurs in this reaction too. 2 silver atoms each donate an electron to 2 oxygen atoms. Alright, let's take a moment to review what we've learned. We first learned that highly reactive metals react with dilute acids, water, and oxygen. Evidence of the reaction with a dilute acid is the formation of hydrogen gas bubbles. These reactions involve the transfer of electrons from the metal to the hydrogen atoms. The evidence of the reaction with water is the generation of hydrogen gas and the raising of the pH of the resulting solution. The reaction with oxygen involves electron transfer and is observed through a change of color. We then learned that less reactive metals react with acids and oxygen, but not water. Hydrogen bubbles are generated with the reaction with dilute acids, and corrosion is observed with the reaction with oxygen. And finally, we learned that the least reactive metals only react with oxygen. Evidence that this type of reaction occurs is a thin layer of oxidation that can be observed on the metal.